So here we are wrapping up chapter 8 and still looking at sine, cosine, and tangent for this, but also getting into something called vectors. So you need to know that a vector is a quantity that describes two things. That describes both magnitude and direction. And I always think about that villain in the first Despicable Me movie. I'll show you guys a clip in just a second. But he names himself Vector because he fights... actually, let me just show you.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Do you want a demonstration? Oh! Ah! Gosh, it's so difficult sometimes to get the piranha back inside.
Mr. Groove, Mr. Perkins will see you now.
So I love that clip. I think it's great. And hopefully that helps you remember vector too. Vector, the magnitude is kind of like how far something goes. And the direction is the thing that tells you which way, or the direction. When we describe a vector, we have to talk about the initial point, or where it starts, and then the terminal point, because it's going to be going in a certain direction, and then how far it takes to get there. So it kind of is drawn as a ray, but a ray, you have to remember, goes on forever in that direction. A vector goes on in that direction, but then stops at the terminal point, or at the end of it. And when you name a vector, you put this little, like when we name a line, we put like a line on top. We draw the symbol for vector on top, which looks just kind of like half an arrow going the one way. There are a couple different ways that you can describe the vector. This vector here, we could say that it is 30 degrees, and we would say that it's 30 degrees relative to the horizontal. And if it doesn't give you any other clues, this is probably the one that it's talking about. It might not have that written in there. This one here, however, though, is the same vector, but this one's going to be described different way. So this one here, we could say that the vector is 60 degrees east of north. So these are describing the exact same thing, because if you know that this is 90 between north and east, this would be 30 degrees, or you might even say 30 degrees north of east, but then you'd probably just say relative to the horizontal for that. So I just want to point out that there's more than one way that you could describe these. You need to know how the compass looks. You have north, south, and then you have west and east. Some ways to remember, I always remembered like never eat soggy waffles, or if you just remember west and east spells we. However you want to, label that is fine, or think about that. So then the next thing you need to know when we're discussing vectors is how to write something in component form. Component form looks like this, kind of like a coordinate where you have parentheses, but now we have these kind of V brackets. Component form of a vector would look like this. And let's say that this vector was, we'll say, vector PQ. So PQ would be starting with the initial point here and going to Q. Well, what I would want to do is I would want to describe how that vector is. And I would describe that vector by saying, how does the x value change? And how does the y value change, or what's happening to the y value? So for PQ, you can tell that it's going to the left 2. So I would say that that one is -2. And then it's going down 1, 2, 3, 4. So that would be -4. If I wanted to describe the other vector, let's say that one is CD. The component form for that would be that this one is going to the right 1, 2, 3, 4, and it's going up 2. So it's a little bit backwards from what we're used to thinking when we're thinking slope, because the vector is talking about how the x value and then how the y value change. And then we can do some operations with vectors also. We can add them and subtract them and do some scalar multiplication, where you're just multiplying something by like 3 or 5 or 2. This stuff's not too bad. I'll go through it pretty quick, but you just have to think about like what's happening each time. So actually for this graph, let's say that this first vector we were going over to the right 4 and up 2, and then let's say I have another one where I go back like this, and I want to see how those add together. So this first one is 4, 2. That next one would be -2 and +2. So the overall change would be +2 and then 4. And you could think about just like adding together the parts of the vector that are in the same corresponding place. And that's how you could do your vector addition. So for this one here, we want to take vector t minus vector r. So I would write out vector t is 1, -2, meaning it's going right 1 and down 2. And then I'm going to subtract from that all of vector r, which is 3, 4. You just have to remember here that when you subtract, you really add the opposite. So I would go ahead and just change that and then add these up. It's kind of like adding like terms. When you're adding vectors, you're just adding like the same corresponding places. So 1 plus -3 is -2, and -2 plus -4 is -6, and that would just be your answer to this. You might not even have to write it out like that, and that would be okay. For the next one, I am going to take vector s, which is 5, -1, and add to that, this is saying 2 times. So you're doing vector t 2 times, 1 and -2. I'm kind of writing all this out. Again, probably most of this could just be kind of done in your head, but I'm writing it out so you can kind of see what I'm thinking. So I have 5 plus 2, which is 7, and then -1 plus -4 is -5. So when you do that vector addition plus that scalar multiplier, this would be your final overall result. And then for the last one, I have s, which is 5, -1 minus t, 1, -2. I like to actually go through and write down that I'm adding the opposite so I don't forget anything. The final answer to this would be 4 and then 1, meaning that the overall result would be going to the right 4 and up 1. And then lastly, I'll do a couple examples of these because I feel like this is probably where you're going to need the most help. What we want to do is we want to find the direction and magnitude of this vector. And what they're assuming here is that we are starting at the origin, and this vector is going from going left 1 and then up 4. So this is the direction of that vector. The magnitude tells me how far, and for the magnitude I can use the distance formula or use the Pythagorean theorem. It doesn't really matter, you know, which way you think about that. So if you're thinking distance formula, your initial point is at 0, 0, and this ending point is at 1, 4. So for the magnitude, I would do -1 minus 0 squared plus 4 minus 0 squared. This is going to be 1 plus 16, or the square root of 17. And you could honestly just leave it like that. That would be okay. And for the next one, for direction, kind of the whole reason why they have this in here is I want to find this angle if I make this into a right triangle. So you actually have two different options as to how you can make this into a right triangle. I'll use this one here, but you could have also gone straight down and over, and your final answer is just going to kind of change based on how that looks. I'm going to call this angle, I'm actually going to use a Greek letter called theta. You'll see this a little more if you choose to take physics. I think Miss Gramling uses it a lot. Shout out to Miss Gramling. And I would just look and see how long these sides are. So this side here is 1, and this one is 4 units. I want to find that angle, so I'm going to set this up. Tangent of theta, or use x if you want, is opposite over adjacent. And then I'm going to just type this into my calculator. I have it in my hand. You guys can't see it. Hopefully you have your calculator out too. This angle is about 14.0 degrees when I round to the 10th. And I am going to ask that you round to the 10th. Okay, so we got to talk here. This is not the final answer. What we want to do when we describe this is we want to talk about what this answer is in terms of that horizontal. So we want to talk about what this angle is here. Well, this is 90, and this is 14.0. So that entire angle, the direction, is going to be about 104.0 when I round to the nearest tenth. So this is the direction, this is the magnitude. If you'd rather change that and say that that's about 4.1, that's fine, you can write that too. I don't really care the formatting of that. So I'll do one more example with you, and then you'll practice this a lot in class. Okay, and then for this one here, again, starting at the origin, I'm going to kind of graph out what direction this is going. So this is 7 and then -5, meaning it's going to the right 1, 2, 3, 4, 5, 6, 7, and down 1, 2, 3, 4, 5. So for this vector, I want to tell the direction and the magnitude. And if you'd rather draw your triangle first, and then you could just do Pythagorean theorem to find those parts, that's fine. This would be 5, this would be 7, so the magnitude, I would just do 5 squared plus 7 squared equals what number squared? So 25, 49, this is going to be 74, or the magnitude is going to be the square root of 74. And I'll just leave it like that. Again, if you'd rather change it to a decimal, go for it. The next thing I want to do is I want to find this angle because that's going to be part of my direction. And the angle is going to be the tangent of that, the opposite over the adjacent. So again, I'm just picking up my calculator. Inverse tangent of 7 over 5 is about 54.5 degrees. That's not the final answer though, because I'm talking about what this is in terms of the horizontal. So in terms of this horizontal, this is 90, this is another 90, or you could do 180, this is another 90 or 270. So then I have to add that all the way over here. So I'm going to add that to 270. So that direction is going to be 324.5 degrees, and that's from the horizontal. Yes, there are different ways you could describe this. You could describe this as like how many degrees south of east, but this is the way the answer will look in the book. It'll be from the horizontal. You always go around counterclockwise when you get that. So you can maybe make that note too, and remember if you're going like each axis would be another 90 degrees, and you can just add that on to whatever that angle is that you get. If you did draw your triangle this other way, let's say that I drew the triangle this way, and I had this set up and I was finding this angle, well then I'd have the tangent of x equals, whoops, that's a 7, 5/7. So this angle would be about 35.5 degrees, and I could just do 360 minus 35.5 and get that same answer over here that I have. Again, this is the answer the way it's going to be written in the book, so when you're checking work or whatever, that's the answer that you want to get. So we'll practice this in class, and I hope this is very helpful.